Perfect. So I have to tell everyone here that I'm not from the Kubeflow ML AI world, so this is completely new to me, but I am from the service mesh world. So I'll give you a Istio 101 if you wish. We do have, I have a last slide and I'll post it in chat later. We do have free trainings as well on Istio if you're interested in getting more involved into different topics and all of these things. To be honest, 45 minutes is not enough, right, to dive deep into everything. So I'll try to maybe I'll go way faster than you would want me to go. But as I said, there's a bunch of resources that we have, courses, free courses that you can go through. All right. So my name is Peter. You can find me on Twitter. I've worked at Oracle. I worked at Microsoft. I've been in the industry for a long time. Past 5, 6, 7, 8 years, I've been working on and with cloud native stuff, things like Kubernetes, serverless, Istio, service meshes, and so on. All right, so one of the best ways that one can understand systems and why we build things that the way that are built is to understand the problems that they were built to solve. So this is the critical context for the solution. So the problem statement that motivates Istio is this one. So the shift to modern distributed architecture left enterprises unable to monitor, connect, manage, and secure their services in a consistent way. So as we take the legacy infrastructure, so any monoliths or sometimes even services that you have, they're typically deployed into static environments, so environments that doesn't change very much. And once you do this move into the modern architecture, you can run into a lot of problems. Now, the biggest thing behind this move to distributed architectures is the desire for developer velocity. So you want your developers to be able to do more things and faster because that's what the businesses require. So what you want to do is you want to decouple things from each other so your developers can move independently and go fast. Now, all this sounds great, and it is great in the end, but there are some problems, right? The tooling we have today does not necessarily cope well with this new world. So this new world where things are dynamic and they communicate over the network. So there are problems that we have to figure out, rather solution for the problems that we have to figure out, things like how do we do monitoring, how do we connect, how do we manage, and how do we secure the services in a consistent way. So when I'm talking about distributed architectures, what I mean is service-based architectures. There's probably in containers, things that are deployed into dynamic environments. Thinking about Kubernetes, right? Pods can come and go. They change the IP addresses dynamically on the fly all the time. And this is in the direct contrast to some of the VM-based systems that were traditionally deployed, like applications were deployed on a VM that had a persistent IP address and that was running an application for years. In short, if I would summarize all this, single buzzword, microservices. So Istio was built to solve these problems. So let me quickly go through a couple of problems that Istio solves, bigger categories. So talking about monitoring services, what we really mean is we're trying to get some visibility into the state of your system. So you have to understand what's actually happening in the systems. There are 3 key ways you can do this. You generate metrics about the services. So as the requests come in and as they go out, what you want to do is you want to publish the metrics and then have another system that can consume those and give you a summary of what was happening, right? So how many requests had 500s, 200 responses, and so on. You also want detailed logs, right? So these metrics gives you a good way of, or a good view of your front door, so stuff that goes in and stuff that goes out. However, the metrics don't necessarily give you a lot of insight into what's happening. And this is where you traditionally would use logging. Finally, tracing. This is the newest one of the 3. It's like logs on steroids, right? So rather than just printing out your log statements as the request goes to the system, what you can do is you can attach data or annotate that request that goes through different services, and then propagate these traces through the whole flow. So you can see for one request that was made at the front door, and you can see what was happening as the request was flowing through different services. And this is extremely powerful. You also want to connect your services together, right? One of the goals of Service Mesh is to push the network abstractions. So the network abstractions being are things like service discovery, resiliency, so things like retries, outlier detection, circuit breaking, timeouts, and so on, and of course, load balancing. Now that you have all these services deployed everywhere, right? And one of the problems that we face is that when you had a monolith, right, there's only probably a couple of ports your app was listening on, right? And all the communication was mostly internal, right? And the request would get processed, it would go through the monolith, and it would just spit out the results, right? So when we talk about securing these things, back then it was relatively simple, right? Because you could lock down any port that's not needed, right, by the application, and then you can start applying IP rules to control who can communicate with the monolith and who cannot, right? And that works great in a static model, but when IPs change, if you think Kubernetes pods, right, this traditional model breaks down and becomes brittle. So instead, what we really like is to have that fine-grained control on who can talk to whom, service-to-service communication management. And then within that, what I'd like to do is I like to say for specific requests, whether they're allowed or not, based on some request properties, or whether to route the traffic from one instance to another instance, right? So you want to get that fine-grained control over where and how the traffic flows and what traffic is allowed. So you can do things as routing the traffic based on L7 metadata, so headers, path, and any other request properties, right? And then, of course, doing the same for applying the policies, right? Making decisions based on the L7 metadata. Finally, securing all this. Now, today, the identity primitive that we use most is the IP and the port pair. Again, that doesn't translate well to the dynamic world, right? So the idea is we would like to issue identities to workloads themselves. And before we want to issue that identity, we also want to make sure that the environment in which the workload is running in is appropriate and that the workload itself is good as well. So an example here is you don't necessarily want your developers to build something on their laptop and then deploy it to the production environment and get the production identity, right? It is the wrong binary, it's the right environment, but it's not a vetted workload that went through your build system. On the other hand, you also don't want your developer to run a production binary on their laptop and then get a production identity, right? Right binary, wrong environment. So if I can verify those two things, if I can authenticate the environment, then I can also authorize the issuance of workload identities, and then I can use that identity at runtime for policy. So Service Mesh touches each one of these areas and actually provides all these features that I talked about. But one of the coolest things about the mesh is, in a way, how mesh centralizes control. So all these features that I talked about are typically implemented or were typically implemented in something like a client library, right? So Twitter was very famous for having done these things in a library called Finagle, and then the original Linkerd wrapped that in a binary, right? But and this is like using client libraries. This is tried and true thing, right? And Google did the same thing with their client set libraries that handled all of these concerns as well. Now, the problem with this is updates, right? So what you have to do is, if you're using the library model, is you have to go to the individual teams and you have to say, hey, rebuild and redeploy your binary so you can pick up this new version of the SDK. Now you have to start doing coordination between between these different things, because some teams will update slower than the others, and some versions might not be compatible. And there's like a slew of problems that can get introduced because of this, right? So these systems didn't really offer any form of centralized control, right? So what Service Mesh does is centralizes this control, and it actually empowers a smaller group of people to be responsible for pretty much a huge amount of operational expense. So an example here is centralized metrics team, for example, that's responsible for ingesting the metrics, collecting and presenting these metrics for the entire org, can operate that part of the mesh, and they can affect changes across the entire org just by pushing configuration. So Istio, I'll talk about the CRDs, custom resource definitions that it has, right? You can impact, in this case, the metrics team can impact the entire org by just creating a CRD and pushing that change to the mesh, independent of any other themes, right? So they can own this at a high level, but then you can also have individual teams owning their own configuration for the services, right? And this applies to, of course, security and traffic as well, right? So you don't want necessarily, you don't want to give keys to individual teams security-wise, right? What you can do is you can move that control out of individual teams and into this centralized group. So you can have the security team be responsible for any security-related things in your mesh, right? But then that team can also give and delegate control back to individual teams, right, for things that shouldn't be managed by a central team, right? So it's kind of weird if you would have a central team that's responsible for setting, let's say, retry policies and timeouts for every individual service that the organization owns, right? So this is something that service owners should have. Also, finally, you want any changes that are made to the system to be quick, right? So you have to be able to quickly respond to this dynamic environment, right? If you don't have time, like this shouldn't take hours, right? So what you can do here is, because this is actually, the configuration is decoupled from the binaries, you can just make quick changes with simple config pushes versus rebuilding the whole binary and going through the same deployment process. So what is Istio? Istio is a platform to monitor, secure, connect, and manage your services consistently. All right, so let's talk about how Istio works. So I'll introduce two services, Service A and Service B, that are talking to each other, right? For the purposes of this this explanation, it doesn't really matter what the communication is or what protocols are used. Let's just say it's HTTP, but it doesn't really matter. Okay? Now, the first and the most critical piece of the mesh in Istio is deploying this Envoy Proxy next to every application. So we call this a sidecar deployment. What this sidecar deployment does, or the sidecar Envoy Proxy does, is it intercepts all network traffic that goes in and out of your application, right? And this gives us the point where we can apply all the policies that we want, all the resiliency features, security features, metrics, anything I talked about, or everything I talked about earlier, right? So the network is this interface point with the outside. So, and if you can capture that, right, and being it decoupled from the application, you can do a lot of fancy stuff. So the collection of these Envoy proxies is what we refer to as Istio's data plane. So we have that set of envoys sitting there next to applications. You need a way to configure them and give them some behavior. And this is where Istio's control plane comes in. The control plane lives in a single binary. It's called Istio-D. First piece of the control plane is called Galley. So Galley is, you can think of it as a management plane. It's just like an API server that's responsible for taking in any configuration that you push to the configuration store, it validates it, and then it pushes that configuration to other components in the control plane. Now, the key piece of the control plane from the perspectives of Envoy and the data plane is called pilot. So pilot is responsible for taking the configuration from Galley, right? So configuration here is just like anything in Kubernetes, is a bunch of YAMLs, right? And a bunch of custom resource definitions. So what pilot does is it talks to the Kubernetes API, right? And it combines the information that it gets from the API, and it gets the view of the world, right? With the configuration that we applied to it, right? And it does that, it builds a model of what the service mesh should look like, and then it generates the Envoy configuration and it pushes it to individual envoys that will control then the runtime behavior. For example, I want to split traffic between two different versions. I, as a mesh operator, if you wish, or a developer, I craft that configuration in YAML, and I say I want 60% of traffic to go to version 1, 40% to go to version 2. I push that, it goes to Galley validates it, it goes to pilot, and then pilot combines that information with the state of the world that it sees in Kubernetes, generates the configuration, Envoy configuration, and pushes it to those proxies. Now, in addition to just distributing the network configuration, pilot also distributes policies. Last piece in the control plane is called Citadel, and Citadel is responsible for issuing identities to the workloads and rotating certificates. So what Istio does is it creates X509 certificates. So these are the certificates that you would typically use for HTTPS on the websites, right? Now, the difference is that the certificates that Istio creates are short-lived. We're talking hours versus years or months for website certificates. And what these certificates do, they encode the identity of the service, right? So if I have service A, service B, that certificate actually includes the identity of the service. And that service identity is then used at runtime for policy decisions, right? Can this access this or not? So this identity is also called Spiffy identity. And this gets automatically assigned to each workload in the mesh. So as soon as you create a Kubernetes deployment, right, these identities get automatically assigned. And it basically uses the service accounts that you've assigned to your pods. So Spiffy stands for Secure Production Identity Framework for Everyone, and it just provides this secure identity in a specially crafted X509 certificates. Once you have these identities, then you can start enforcing the policies. You can do authorization, you can do authentication, you can do whatever you want. So to summarize, Istio does the following: it configures the network, it provides identities, and then it distributes the policies to enforce. So if we go back to service A calling service B, and if we actually track the call, so Envoy runs alongside the application, and what it does, it transparently intercepts the call. So if you make a call from service A to service B, Envoy will intercept that call. The way that it does that is IP tables are involved, right? And then configuration that actually intercepts everything. But since we are in the Kubernetes pods, or actually living in Kubernetes, the containers within the pod share the same network space, right? So when we make that IP tables modification, right, it applies to any other container in the pod as well, right? That's the way that Envoy is able to intercept that call. Transparently means that service A is not aware that the request is being intercepted. Service A is just calling service B, right? So once the call is made to service B, Envoy actually determines what the actual destination is. So this involves looking at the endpoints, right, and figuring out which IP address to use based on labels and subsets if you want to do the traffic routing, right? And it picks one destination, and then Envoy forwards the request to it. Now, we don't know if there's an Envoy proxy on the other side or not. So client is oblivious to it. It just makes a call to an IP address pretty much. If there is Envoy on the other side, that sidecar will intercept the request. It will check the destination's identity, and the receiving Envoy will also check the sender's identity. So you have the ability to do the mutual TLS. Also checks the policy to see if the request can be forwarded to the service or not. And this is where you can then apply service-to-service communication policies, right? And decide, can that service A actually call service B or not, right? Before the call even gets to service B. Assuming the request can go through, it will go to service B. The Envoy next to service B will forward that to the actual application. Service B will do whatever it needs to do. It'll prepare the response, and then it'll send it back back to the caller. And then the same thing happens on the way back, right? So Envoy will intercept the response. It'll forward it back to the client that requested it. And then the Envoy on the client side, service A in our case, will forward it back to the actual service A application. Now, while this is happening, right, both Envoy proxies in this scenario also asynchronously report any traces and the information about the request. So any telemetry, any metadata pretty much that they know about the request, right? And this is being collected by Prometheus, Zipkin, right? There's also both of these Envoy proxies expose metrics endpoint that can then be scraped by Prometheus, and then you can visualize it in Grafana. Now, zooming out a little bit, how am I doing on time, by the way? Jimmy?
Yeah, maybe give it another 15 minutes, 10 minutes.
15 minutes? Okay. All right, so zooming out, high level data plane, control plane. Data plane is the collection of Envoy proxies. And then the control plane is this single binary STOD that has the Galley, Pilot, and Citadel. So as I mentioned, the split between control plane and data plane, this is a fairly common split. And the reason for it is because there are different scaling properties, right? Your data plane instances, your envoys will increase with the total number of requests in your system. However, the control plane instances will scale with the number of data plane instances they have to manage, but this is order of magnitude smaller though. So there are a couple of terms to talk about when describing how traffic management works. There's multiple resources, and when I'm talking about resources, I'm talking about CRDs, custom resource definitions that Istio installs. There's a service entry that allows you to bring in any external services and make them part of the mesh, meaning if you have an external API, you can create this resource, and then you can apply any of the traffic routing, timeout management, retries for that external service, right? So it goes through the proxy and it can do all those things. Virtual service is a resource that can be used to configure the routing rules. There's destination rules, the rules that get applied after the routing decisions have been made. This is where you can configure mutual TLS, for example. There's also Envoy filters, gateways, and a couple of new resources that got added with the latest Istio version. So I want to explain the term subset. So in this example, what I'm telling Istio is that I have two deployments of service B, a production one and a staging one. And when I say deployments, I'm actually meaning Kubernetes deployments, right? The difference between two deployments is, of course, the version number of the image that's running, but also the labels that are set on those pods, right? On in your pod spec, right? You set the specific labels that you want to apply to the pods. So one is set to US prod, the other one is set to US staging. staging, right? And these are just the labels, right, in the pod template in the deployment resource. Nothing special. This is all out of the box Kubernetes, right? Now, in order to, and what I want to do is I want to route traffic between these two deployments based on some properties, right? So the first thing that I have to do is I have to tell Istio that, hey, I have these two subsets. These are their names, V1 1.5 and V2.0 alpha. And this is how you can distinguish the pods that are different versions, right? And this applies to two different deployments, right? Now, once I have this subset, then I can use virtual service resource and say, whenever there's a request for service B, right, this is the subset that I want the traffic to go to, and I want to do that for the 99% of the traffic, for example, right? Like the slide shows, we're splitting the traffic 99% to prod version, or actually pods labeled with the prod version, and then 1% going to service B. You can also do the same thing and do something more advanced where you use any of the request properties. This example shows how to use a header, right? And then basically check the user agent, and if it matches that regular expression, go to this version of the service or this subset of the service. If not, go to the other one. Timeout management, where you can set up the timeouts for your services, so you don't have to set it up in your application anymore. You can configure it through a configuration change, pretty much. Traffic routing, resiliency features. There's also a feature called a resource called gateway and an ingress gateway controller that's also deployed as part of Istio. This just allows you to use Envoy Proxy as a traditional load balancer, right? So you can use it as a sidecar proxy, but you can also use it as an edge ingress proxy, right? So this is same as like Kubernetes ingress resource and other ingress controllers, right? So this proxy, what it does, it allows for the north and south traffic, so traffic that's entering and exiting the mesh. And what it allows you to do is to enforce traffic control at the edge. So this is where you can do any authentication. This is where you can do like match for any hosts and then route the traffic based on that to different services running in your Kubernetes cluster, right? And then there's the same thing on the way out, right? So there's an ingress gateway for incoming traffic, but there's also an egress gateway, which is an instance of an Envoy proxy, and it's there to capture any traffic that's exiting your cluster, right? So if you want to monitor that as well, right, you have an option of routing all the traffic outside of your cluster, routed through this egress gateway, and then get metrics, logs, etc. Outlier detection, where you can basically configure the outlier detection and circuit breaking. You can also inject failures if you want, right? You can say, hey, I want to simulate a slow network connection, for example, and I want to set a delay of, in this case, was 7 seconds, right, for all the requests that are being sent to service B, right? In addition to delays, you can also insert errors, right? So you can say, I want this service to fail X% of the time. And well, let me rephrase, not fail, but I want the service to return this specific HTTP status code for X% of the time or X% of the requests, right? In this case, we're returning HTTP 400, right? So this allows you to make sure that your services are resilient. Quickly about authentication. So the identity that's used for the workloads is in form of a service account, right? So Istio takes that service account and uses it as an identity for the service at runtime. This is created by the spec that's called Spiffy. Spiffy just describes the naming convention. It's pretty much just a URL that's encoded in the certificate. So it's a URI, Spiffy : / and then the full name of the, or full path for the service. Encryption in traffic, in transit. So it does mutual TLS by default. You don't have to do anything here. This is by default because the TLS checks is being done by the proxies, not by the applications as well. By the applications. I'm going through the slides because I have a lot of them, but we're almost there, and I'll just show you a quick demo. TLS and the benefits here, of course, right? You can do if your session is compromised, it's not going to affect any other data outside of the specific session. And then rolling out the TLS, there's a mode called a permissive mode. What that means is you can have so you can have one service talking a TLS and another one sending plain text. But with the permissive mode, you can say, I don't care which one is it. I permit plain text responses as well. And then once you move your services over to use mutual TLS, then you can just switch it around and say, now I can require a strict mutual TLS between all the services. If they don't speak that, they'll just fail, right? You can do request authentication. Right, so you can use JOT tokens to authenticate the users. There's a resource called request authentication. What it does, it verifies the requests that are attached to the request. Right, it's done with the JOT token validation. It just configures the value that specifies the token location in the request. Right, you can retrieve it from the headers or from the parameters. Right. And then you can decide which workloads in the cluster you want to apply this request authentication resource to, right? So meaning if you make any requests to any workloads labeled with app HTTP bin, that will require you to have the JOT token assigned to it or attached to the request, right? Of course, you can scope this on the mesh, namespace, or workload level. Now, once you have the identity, the next thing that you can do is you can do access control, right? You can perform an action on an object, right? And you're basically answering a question if a principal can perform an action on an object. You, in this case, is a service, right? Same as an object. And then the action is actual request that you're making. Is this HTTP? Is it get? Is it post? Is it put? Is it delete? And so on. So here's a quick example of this authorization policy, which basically this resource provides a combination of a traditional RBAC and the binding into this single resource that's called authorization policy. And here's where you can use the selector to scope or target this authorization policy and then apply the policy to only specific workloads. The second part here in the resource are the rules, right? And this is where you can actually define what's allowed, the traffic that's allowed. So from field, you can define the list of source identities, namespaces, principals that are pretty much allowed to call the services you apply the policy to. Then you have the to field, which defines which methods are allowed to be called. Is it a path? Is it a method, or all methods or all paths? And then finally, you can say when, right? You can combine the service credentials defined in the from field with the user credentials, for example, that you obtained from request authentication resource, right? All right, so quickly demo, I'll be very fast. So I have a web front end. I have two versions of a customer service, and then we'll just do a simple traffic routing. If I can find my resharing the window here. Let me find this one. Okay. All right. So you should see my Google Cloud Shell.
We see it.
Perfect. It should hopefully load soon. There we go. I do have a Kubernetes cluster running, and I've already installed Istio on it. Let's click authorize here. There we go. So I have Egress Gateway, I have Ingress Gateway installed, I have STOD, this is the control plane, and then I also have Prometheus, Kiali, Zipkin, and Grafana installed on it. So these are all optional add-ons that you can install. Also, let me just show you the services, Kubernetes services I have. And you'll notice I have this Istio Ingress Gateway of type load balancer, and I actually have an external IP address that I can access, right? So if I make a curl to this, there's nothing there because I don't have any configuration deployed that would tell Istio how to route the traffic. So the first thing that I'll deploy is a gateway resource. And I'm basically saying, I'm configuring that Ingress Gateway workload that I have, pointing to it with this selector, and I'm saying, hey, allow any hosts port 80, right? Just do that. And this configures it. And you'll notice that this time I get a different response. I actually get a 404, right? Versus previously the connection was canceled. So next thing that I'll do is I will deploy my web front end. It's just a deployment in a service. And then I will deploy the customer's V1 deployment. And then let me show you, you'll notice that there's 2 out of 2. So one is my application, and the second container in the spot is that Envoy Proxy, right? That's running. And this is automatically, I've labeled the namespace, my default namespace with Istio injection enabled, meaning Istio will listen for any new deployments and it will automatically inject that proxy to the pod. Next, I have to configure my virtual service. And I'm basically saying, I'm attaching a gateway to it, which means I want this service or this destination, wherever it routes to be accessible through my gateway. Any hosts, I don't care what the hosts are. Over here, what you could do is you could say www.hello.com, right? And then go to your domain registrar and do the DNS records magic there. A record, point to your Ingress gateway, the external IP here, and then you would get the domain to work. So now if I go and open this web page, I think I shared my whole window, so you should see this, right? It's saying, welcome to the web front end, and it's just returning a list of customers. So it's calling, when I go to this IP, it goes to the web front end, and then the web front end makes a call to the customer's V1 service. So now if I want to deploy customers V2, what I have to do is I have to tell Istio, hey, I'm going to have 2 versions, right? I want to define some subsets. So I'm defining a subset called V1 and V2, and then setting the labels for those 2, right? Next, I want to say, well, route all the traffic, virtual service, route all the traffic to subset V1, right? So any pod that's labeled with version V1 on this host, right? So that's what's going to do that. And then if we just deploy the second version of customers V2 is just using 2.0 version, create this deployment. And then we can do things like route traffic, right? So let's create 2 destinations for the customer's default SVC cluster local, which is the fully qualified name of the service in Kubernetes, 50% to V1, 50% to V2. You can do the split however you want. So once this is, and I have everything running. So if I go back and I refresh the page a couple of times, you'll notice that I get different responses. In this case, I get a city column as well, right? And this is just showing you how the traffic is being split. Now, one last thing, really quickly, I'll do istio-ctl-grafana. As I said, there's Grafana, Zipkin, and Kiali are some of the add-ons that you can install. And all these dashboards are there automatically. I didn't have to do anything, right? And you have web front end, for example. Oh, look at that. of course, the demo will break. Let's try again. Let's do service dashboard maybe. Anyway, what I wanted to say is all this data is collected automatically by the proxies and then reported by the proxies to, well, Prometheus is scraping the endpoints, right? And then Grafana is just using that as for its data source, right? So that's, I have one single slide that I want to show and put it on video, just so people can refer to it. So set of resources, of course, official Istio website, Istio.io. Tetrade Academy, this is where we have all our free courses. If you want to do the Istio course, it's like 4 hours. You go through it, labs, everything. Tetrade blog, and we also do a bi-weekly Istio stream called Istio Weekly, and it's on our YouTube channel, and we're talking about everything Istio pretty much.